They look at it and they say, "Oh, I understand that," and they move on. And it goes from their eyes to their mouth, and that's it. It never goes through their brain. It just doesn't register. But if you show them the process of solving the problem, so that it's not all just presented to them as a deus ex machina, as a finished thing, a fait accompli, they actually have to think about the process as you're going through it. They almost can't avoid it. And it's an incredibly useful instructional tool in that regard. And that's not just true in math. Any concept that has to be built upon itself, step by step, in any subject can be presented this way. So, so I'll subtract, if I do anything to both sides of the equation, the same thing to both sides of the equation, I maintain the validity of the equal sign. So 2x squared plus 20 minus 20 equals 52 minus 20. So the 20s cancel out, and 52 minus 20 is, help me with that, 32. And so 2x squared is equal to 32. Well, next, of course, I'd probably no, don't do that. It's sensing the tip. So, so if I divide both sides of the equation by 2, again I maintain the validity of the equal sign. So x squared is equal to 32 divided by 2 is 16. So now I can take the square root of both sides of the equation. So x, square root of x squared is x, square root of 16 is?
Plus and minus. Has to be both.
Plus and minus 4.
Plus or minus 4.
Since we're doing
Very
the
good.
problem.
Plus or minus 4. It is a quadratic equation after all. Okay, so that's a board case.